So welcome back to part 2 of module 1, where this is my favorite topic, let me tell you. So talking about the statistical insights. So we will not go deeper into statistics because the module is on Power BI and talking about data analytics using Power BI, but definitely you would require a small understanding of how stats work and very minimum understanding. And this module onwards we will start demos and a lot of hands-on exercises, and I will tell you about the data sets and all these things in the next module when we talk about the Excel self-service BI. But this one dedicated to statistics, and that too descriptive and inferential statistics. So both are there definitely. So talking first of all about the central tendency, we will see mean, median, mode, and these kind of things we will be looking forward to. And also we will see the estimation hypothesis. So that is the higher level of statistics. We call it as the inferential statistics. So we will talk about both the things in this particular module. So inferential statistics may not be in detail, but descriptive statistics is what we are going to see in this module, in this part of module 1. Okay, so here we are. So primarily the entire arena of statistics is moving around the summarization of data, consolidation of data. Because without summarization and consolidation, you cannot get inferences out of the data. So the main objective is to get inferences, insights out of the data. That's all. That's what everybody is trying to do today. Now, if you talk about the components, if you talk about how descriptive statistics help us, so I will talk about definitely the measure of central tendency. So central tendency, if you just hear this term next time anywhere, so please be aware that we are talking about the three terms, very common terms, mean, median, and mode. So mean, median, mode, let's have a deeper look at this particular three terms. They are very commonly used terms, and we will see direct examples of this, right? So first of all, mean. So mean is very simple. You just don't be so mean. It's not that mean we are talking about. So we are talking about mean as a sum and division of count. That's it. So sometimes we, mean means actually we can call it as the average of the values, the mean values. So what happens is you take up a sum and then you divide it by the count of the numbers. So let's take an example. So one by one we will take this example. So I have just opened an Excel sheet for this purpose, and here what is happening is I have given just some random numbers I have just chosen over here. So by the way, I am using Microsoft Excel Office 365 version, the latest version of Office, Microsoft Excel. And I will be telling you so many, or let's say giving you insights about so many features of this particular tool before we proceed to the Power BI section. Okay, so keep in mind this one. Very simple. We say, what is the mean of these numbers? So mean of these numbers, the first thing that we need to do is we first of all take the sum of these numbers. So we take the sum. So this becomes sum of the number, and then we need to find out the count of the numbers. So we say is equal to, so these, I think whatever we are using right now, so whatever terms we are using, sum, count, mean, they are all part of the descriptive statistics family only, right? So for finding out central tendency, means mean, you should know what is sum and what is count. So these are the basic things. And then what we do is we take the count. And then when I say, let's find the mean, so mean will be nothing but this sum divided by count. So 18 is the mean of these numbers that you have. Here, the order of the numbers doesn't matter. I mean, it could be in any form. But then when you move on to the next section, which is, let's say, after mean, we have median. So for median, we need to arrange the data. So median is actually the process of finding the centralmost number of a series. That's called median, right? So mean, we understood, kind of an average concept, right? So sum and the count. Median means you try to find out the most central number, right? So now if you go to mode is nothing but calculating the frequency and the occurrence of a particular number in data set. Okay, after that we have variance, and then we have standard deviation. So we will be talking all these things in detail, but so first of all, let's understand the median and the mode. So median and mode we understood in terms of theoretical description. What is our definition? Let's try and see this from the perspective of Excel. So consider that we have these numbers. So these are the numbers that we want to find the median for. The first thing that we need to do is to sort these numbers. So to find out the median, the first procedure is to take the sorted order is important, right? So I'll tell you why this is important. So what we need to do is we sort this number. So I sort it and I say smallest to largest, largest to smallest. It's absolutely fine. So this data is now in sorted order. Now median says that we need to find the centralmost number. So centralmost number has a quick trick over here. If the count of numbers in the data set is odd, then in that case what we do is we just find out how many are there, and then we get the central. Suppose if there are 13, so we say n plus 1 means 13 plus 1 14 by 2 means 7. So the seventh number. So I'll just give you an example. So how many numbers are there? Let's say we have 12 numbers. So this is not numbers are not odd, it is even. So the number of numbers I'm talking about, number of facts in this case. So if it is let's say I add one more number over here. So if I just add a number 34, let's say, which is a bigger number because it's already sorted. So if I have this number, 13 numbers are there. So what I need to do as per the logic, so it is n plus 1 by 2. So 13 numbers are there. So I need to say 13 is n. N means count of numbers in the data set, and you say plus 1. So plus 1 means 14. So we need to find out the seventh number. So I say this is number 1, 2, 3, 4, 5, 6, 7. So 12 is actually the median. Now consider that, this is one of the cases. So what I do is I take up the same number, and this time what I do is I remove the last number, let's say. So now if I just wanted to find out the median, what I need to do is I need to do a small calculation. So what I need to do, so first of all it will be, because it is even. So first of all what we will do is we will take up the n plus 1 by 2 concept. So suppose we will take 1 will be the sixth number and the seventh number. What I mean to say. So because it is 12, so what we will do is we will take up this number, which is 11, which is the, so 1, 2, 3, 4, 5, 6. So the sixth number and the seventh number. And then what we will do is we will say is equal to 11 plus 12. So this is there. So 23. And then how many numbers are there? So there are 12 numbers. So what we will do? So this is the numerator, we can say, and this is the denominator. And then if we find out the median, so median would be this divided by Denominator will be 2 because we have done 2 medians over there. So the median would be 11.5. So you now saw that, okay, here the median was 12, and the moment we went to the number of values which are odd, so we had to take the middle section of it and increase it, and then take the 6th and the 7th, I mean the previous and the next, and then by 2, and you get the median. Next comes mode. So mode is very simple. Mode is like, okay, how many times a number is appearing in your set. So if you look at this particular section, so where you have, let's say 18, 15, 14, 12, 11, 9. So it is clearly visible that if you talk about mode for this numbers, so it is 15 because 15 is appearing twice and rest all are in one place. I mean, the frequency is only 1. So now this is actually unimodal, you can call it as. So this is unimodal. So this is a unimodal number, right? So which means only one number to be recognized as the mode of that particular data set. But if you go here, you will see that the system, the scenario is different. So you have 2 and 7 which have the highest number. I mean the frequency is the most, right? So in that case, you will call it as 2, 7. So these are the modes. So in that case, we call it as bimodal. So one is unimodal and one is bimodal. So if you have 2 modes, then you call it as bimodal. If you have more than 2 modes, so we call it as multimodal. So unimodal, bimodal and multimodal. So these are the 3 concepts that you should always keep in mind when we are talking about data. So when we will be doing data modeling and data preparation, so these concepts will be very, very important when we are doing some calculations and making measures and stuff like this, right? Apart from that, there is another term called range, which is very simple. To find a range, what we need to do is we need to find out the maximum value and we need to find out the minimum value, and then what you need to do, we need to subtract, right? So to find the range, what we do is we find the max, we find the mean. So is equal to max, and we say is equal to min. And so the range would be is equal to max minus mean. So the range of these numbers that we saw is actually 6, right? So this was very basic of descriptive statistics, what we call it. And this is the fundamental part of descriptive analytics. So what has happened in the past, what we are going to do is we are going to do some statistical analysis on top of this. So to do this, we use descriptive statistics. So let's proceed further and see some other components or other terms that are used in descriptive statistics. We need to talk about the measures of dispersion. Which means how the data is spread across. One side we talk about the numbers and how do we formulate and summarize and all. Another side is just the opposite, where we talk about the dispersion. So if the data is getting spread across a particular location or a particular data set, so how do we make sense out of that data, right? So there we need to use 2 terms which are very important. One is called variance and another one is called standard deviation. So let's have a quick look at these 2. The concept is very simple. So first of all, to understand the variance, we need to find the mean. So mean of a set of numbers, we have already seen that. And then what happens is, if you want to find out the variance, we need to subtract the number or in the data set with the mean and then square it. And then finally we get that ultimate number, which is the variance. So here we see the example. Similarly for standard deviation, so standard deviation is nothing but the square root of variance. So first of all, we have understood how to calculate the variance. So now what we are doing is we are actually finding the square root. So once we have got the variance, we just say square root, and whatever we get, that is actually the standard deviation. So now you know the terms very well, what are used in terms of, and it is denoted as sigma. And so I mean it depends on the sample size also. So based on sigma, so that's why we have seen I mean +3, -3 sigma, and then that's what we have concepts like 6 sigma, right, in any kinds of analysis that we do for any given business, right? So you can see that this mean is an integral part of any analytical process that we do, right, or what we achieve. So the first thing we talked about the I mean mainly the variance, we talked about the standard deviation, and now when we talk about coefficient of variation, so that's the again an important thing that we are going to learn in our subsequent slides and other things, and we will see the coefficient of variation. So coefficient of variation is nothing but the standard deviation by the mean. So we have calculated the standard deviation, and from the standard deviation we find out, and we divide it by the mean of that particular data set, and we find out coefficient of variation. So now all these things that you are seeing over here, they are theoretical. I mean, understanding it from the theoretical perspective. We will now move on to the practical part of it also. But before that, let's have understanding of the other terms, related terms also. So one of those terms is quartiles. So quartile, first quartile, that's the lowest quartile or the lower quartile, what we call it. The 25th percentile, from 0 to 25th percentile, we call it as the first quartile. And then we go to the second quartile, which is actually, we can say the median is also coming somewhere over there, and that's the 50th percentile. And then we have the upper quartile, which is the 75th percentile. So at any given point, data can be divided into 4 quartiles, 25, then again into 25, 4 sections, and each of them can be called as a quartile. So quarter of a data, that becomes quartile. So what we are going to now see is that how the mining of data starts. In definitely not in terms of directly, because Power BI we will be moving on to. Before Power BI, we need to have a quick understanding of how the statistical things work, and we are going to do a simple example in Excel itself, and then we will move on to the self-service BI techniques. So creating of models, creating of analysis using the advanced BI technique. So again, the statistical analysis comes into picture. So it's actually time to do a particular demo from the statistical standpoint. But before that, let's understand that when you are conducting such analysis, what are the guided principles that we follow over here. So always remember that whenever you are talking about data analysis, we need to be very careful about the source of the data. So from where the data is coming, that should be an authentic source, and how you are fetching that data, how you are bifurcating the data, segregating the data, those things are very, very important in terms of data analysis. And we need to also make sure that we segregate data as critical data elements and the non-critical data elements. So first of all, when you look into the data, we need to first of all find out that, okay, do we have any attributes which are critical to my data set? So those all things, and based on that, we need to progress or proceed with the analysis. Privacy requirements are also important to be taken care of, and data accessibility, given access to the users, the stakeholders, is also one of the important tasks of performing data analysis. The journey starts from the mining, understanding of the data since the beginning, to the disbursement of the data or sharing of the data with the stakeholders. It's a complete journey that we take. So these are actually the 10 guided principles that we are going to, we follow usually. And always remember the data dictionary is an integral part of any kind of data analysis. So when we talk about data quality and framework, build up of a framework, so they are all part of data analysis, right? So they actually analysis of the data. It's not a single term that you just take up a data and then do a chart and then give it. It's a journey actually. So it defines the entire process of how do we acquire, clean, and then visualize and then present the data. So definitely the term visualize comes into picture over there. So we will be talking about this in detail, but just for your knowledge, because we are going to see some inferential statistics also in this, talking about the linear regression part and all. So definitely we will be making some charts. So visualization is a part of that, and we will be making charts. But apart from chart, you can see that there are other factors also. We have maps, networks, time series, hierarchy, matrices, and today we have infographics also, which are an integral part of any data visualization that we perform. So now let's get into the demo. And this demo, what we will do is we will understand the terms that are used in regression analysis. So until and unless we have a closer look at analysis, BI would not make complete sense, right? So it is very important that we highlight the terms, highlight the practical approach of how regression analysis happens. So let's see the method. Let's see how the factors are considered, and what are the things that we need to take care when it comes to the analysis part. It is also evident that this linear regression technique is used for predictive modeling as well. So that is also an important thing that we need to take care of. So it's time for a demo. So it calls for a demo, and we take an example. We take an example data set over here and then perform our analysis. So are we ready? So yes, we are ready. I can hear you loud and clear. So we have taken some data, and this is like a very simple revenue data. Revenue of a company and the CEO's pay. Now, where this starts and how it starts, how this, approach starts actually. So let me tell you about the story behind this. So there was this company, a logistic company, and the HR of this company, the HR manager, so she came to me saying that, hey Rupam, you know what, it's almost around 28 to 23 months, months that we are into business. And since the beginning, we have been tracking definitely the company revenue and the CEO's pay that we were giving. So let's begin with the demo of a statistical analysis. So here comes. So we have got an Excel file from an organization. So let's talk about the story behind this and how do we actually work with this file and what is the inferences that you can get out of this particular file. A very simple file to understand the story, and this data is will be available to you in the form of a data set. So you can also have a look at the output, and you can also have a look at the input file. What are the differences? So there will be a file in the data set called revenue.csv. You can pick up that particular file and do your analysis. There are multiple other data sets and data sources that I have provided to you in terms of completion of the course in a successful manner, right? So that's the agenda. Please remember. So what happens is this HR manager comes to us and says that, hey Rupam, you know what, we are into this business for almost around 28 to 30 months now, and we know that the company's revenue and the CEO's pay, they are correlated. We know that, right? So based on whatever HR policies and whatever calculation and other things, we have been doing this manually for quite a long time now, because for doing any kind of statistical analysis, we were told that we need some good amount of data. I said, yes, that's absolutely true. How much data you have? So she says that, okay, I have 30 months of data. Now, what is the ask? What is your pain point? What is the problem? So this is how you interact. See, this course is not only, please understand, this course is not only to just show you these are the menu items and then do this. Understand the logic, understand the story, understand the pain point behind this, and then proceed. So says that, okay, company revenue, 30 months of data. So what is the pain point? So I said that, okay, what is the challenge that you're facing? So you say that every month we have to do a lot of mathematical calculation to find out how much should we be giving to the CEO. And I said, how do you do that? So she said that, okay, we use that mathematical functions. I mean, this linear regression I'm talking about. And we try to forecast this particular number mathematically on paper, or in other ways in Excel, or howsoever it is in. So it's a long procedure. So because it is CEO's pay, I mean, so we need to be extra cautious about what we are paying. So we just cannot pay something like this. So the first pointer, I told her that, to get any kind of statistical inferences, you require minimum of 50 to 60 data points. What you have right now is 30 data points. We will try. We will definitely try, and we'll see how it works and what is the inferences that you can draw out of this. So we start our process. We are super excited. And what we do is we have company revenue and we have CEO's pay. Now something comes in our mind that we have already gone through. To do any kind of statistical analysis, we have three tools with us. Procedures, what we can call it, right? So one is we try to find out a trend within the data. Second is we try to find out correlation within the data. And then third is to find out the anomalies within the data. So now if you talk about trends, so because we are trying to find out the pay of the CEO, which means we are trying to predict something, definitely given these two data points, A and B, we need to first of all find out whether these two have any correlation. If correlation is there, then definitely we will be able to do what? We will be able to do the analysis, or we will be able to predict the future. So what we do, how do we do correlation? So for correlation, so we will go, when we go to data visualization, we will see what are the different techniques. But as of now, just for FYI, your understanding, to do correlation, to check correlation, we use a scatter plot, right? So here also we will be using a scatter plot. So we select the data. So we have 30 data points, and we go to insert, chart, and what we get is a cloud of data. So remember these blue dots that you see on your screen. So they are called as observations, and we have 30 observations over here. So what we need to do is we need to find out that what is the measure of correlation between them before we could do any kind of predictive analysis or predictive modeling, right? That's what we are doing. So always remember that whenever we are doing this kind of analysis, the first thing that we need to see is the spread of the observations. So you can see here, the spread of the observation is very, very minimum. So we can see the cloud is over here. So it's very important to magnify this data to do any kind of analysis. I think you will all agree to this. So we do the same task. What we do is, first of all, now we see that So in this vertical axis, we have the CEO's pay, and in horizontal axis, we have the company's revenue. So we see that the pay of CEO was never below this 200K, right? So what we do is we go to the format axis and we see that it starts from 0. So what we need to do is change it to 2 so that we can magnify this. So it magnifies. Similarly, we see that if you talk from the company's revenue perspective, the company never had a revenue below 25 million. So definitely there is no point giving it as 0. So we started from 25. Suddenly you see that the data points have spread across. So the reason spread across means because we have increased the axis points right over here. Now it is visible that there is a correlation, and if we go towards, if we just go back to our first part of this module, so we will see that this is a positive correlation. This is called a positive correlation. So, directly it is visible. But now I can go with this inferences to the HR saying that there is a positive correlation, please go ahead. But there should be a measure of this correlation, right? So what we need to do is, please watch this carefully. Remember, it is not mandatory to have, since we are talking about Power BI only, so it is not mandatory that everything needs to be done from, so the Power BI part, the introduction will only make sense when these things are clear to you, because in Power BI, we are not going to discuss this. So in Power BI, it will be like the advanced things, that getting the data, churning the data, modeling this data and visualizing the data. That's what Power BI is meant for, right? So, but this is an integral part of any kind of analysis that you do. And because the data is small, mandatorily, you don't have to go to Power BI every time to do this analysis, right? So what we can do is we can just come here and say, add a trend line, and it creates a trend line for us. Surprisingly, it opens a window called format trend line also, and it says that, you know what, I can see that this looks like a linear regression line, and I can give you some insights over here also. What are the insights? Remember the data insights that we are talking about. So this is the insight that we are looking forward to. So what happens? It says that I can show you the equation, and also I can show you the R square of the data sets that we have. This is a very simple spread of data, and if I just look at in this format actually, so this is a right blend of understanding the statistical analysis of any kind of data that we visualize or we tend to visualize. So it says that, remember the equation y is equal to mx plus b. So don't you think that this is in the same lines of y is equal to mx plus b format? So yes, it is in the same format. So now what we need to do is we need to see that we have y is equal to mx plus b, and we have another part called r is equal to 0.85. What is this 85? So 85 is actually the coefficient of regression. So we talked about coefficient of variation. So in this case, it is called coefficient of regression. So in plain and simple term, this is the value or the mean, you can say, of the distance of these dots from the line. So there is a line, and there is a, so what is this line called? This line is called the best fitted line. So best fit line, right? So this dot from the line, this distance is called the residual distance. And then hence the term R comes into picture, right? And we can just find out the distance between all these dots, and we can collaborate them, and then we can make R. So now R, why it is squared? Because you can see that some of the dots are below the line and some of the dots are above the line. That's why we use square, so that it negates you can call it as the power of negative or the negativity or the negativity of the number. So now we find, so we can call it as, straight away we can call it as predictive analysis, right? So the moment I found this, so as per our understanding of statistics, 0.85 means 85% is a very good number, is a very good, you can say a value in terms of data correlation. So I immediately ran to the HR manager and said that, okay, we have got a very good, number over here, and we can do the prediction out of this. So prediction means forecast, and definitely we have functions for that. So before going to the HR manager, definitely I did something. So I said that let me have a case. So what I said is, consider that the revenue of the company for the next month is, let's say, 25 million. So this is the number we considered. What we are talking about is forecast of the pay. So what would be the forecast? So what we can do is, we can use this y is equal to mx plus b to get that number, or what you can do is we can use the function forecast to perform this task. So forecast function in Excel takes care of this predictive modeling task, and it takes 3 parameters. First is the x value. So it says that, okay, the revenue, that is x. X means what we call it as independent variable. So we need to understand what is an independent and what is a dependent variable. So independent means, it is not dependent on anything. It's like in a simple scenario, a simple, sentence, if you call it. So here, if you understand this, company's revenue is not dependent on anything. So it is independent, but the CEO's pay is dependent on company's revenue. So in that case, CEO's pay becomes a dependent variable. So what we do is we say, so dependent is y and x is independent. So we take x and then it says, show me all the known y's. Known y's means all the known dependent values. So these are the known dependent values. So I take all the 30 values, and then what I do is, it says give me the known x, means all the known independent values. So we take that as well. We close the bracket and press enter, and we see that it forecasts the number as well. So this is the CEO's pay given this 30 data points, and it shows that this is accuracy. This has an accuracy of around 85%, right? So we were very happy that we could do the forecasting. We could work on the predictive modeling, and I went to the HR manager. So HR manager says that, okay, when I say that, okay, this is 85% accurate. So, and we see that the correlation between the revenue of the company and the CEO's pay is 85%. Using this data, I can only justify or I can only explain 85% of CEO's pay. This is what it means. So the HR says that no, that is not possible, because our CEO's pay, that is highly dependent on company's revenue. So we do not have any other factor as such. So, but the data is showing something like this. So now, which means that now there is a small problem that we are facing. So the HR says that, okay, this should be more. And I am seeing that as per the data, this is the number that is coming up. So anyway, what happens? I come back to my workstation, and then what I do is, like, I go back to the data, and while I was going through this data, I saw something unusual. So this unusual is this part. So this unusual activity, unusual activity in the sense, we can see that the company's revenue was too high, so high, it was almost the highest company's revenue in that month, but the CEO's pay was not as per the revenue, right? So then what happens is, I went back to this HR manager and said that I see some anomaly in the data. So this is where the term anomaly comes, right? So I say that, okay, I see some anomaly in the data, and we need to understand what is this, how to remove this anomaly, because when we identify anomaly, we have to eliminate anomaly for that as well. So we say that, okay, what has happened in this month? I mean, if you just look at this place, so the revenue of the company was almost touching 39 million, but the CEO's pay was not at par with that. So what we did is we were trying to find out. So these are the things that Excel has got its limitations into. So we cannot do much about this. So what we do is we have to manually find this, and we found that this is the data that we are looking forward to. So 38.15. So if you just take your cursor, 38.15 and 6.935. So this month is an anomaly. This month is it is not matching the pattern of the data that you have supplied me for last 30 months. What has happened? So then she said that, yeah, the revenue was very high in that month, but so the CEO decided to give away some of his pay for that month, and so it was deducted from the salary, definitely the pay, and that's why this number. One statement and the answer was clear. So we see that in 30 months this happened for only once, right? So which means this is not a cyclic effect. It's not that every 27th month, I mean, we asked that, is it that every 27th month the CEO will do this activity? So the HR manager says, not sure, but I don't think so. So this cannot be considered as a cyclic effect. So I cannot consider this for my analysis in that case. So then what I did is since it is Excel, we have to find it manually, and to work, we have to manually remove this and keep it aside. The moment I did that, what happened is immediately the best fit line, if you see, it moved, and the R square now from 85% it has moved to 96.18, 96.2%. So it is almost touching 1. So touching 1 means it is very, very accurate. Or, I mean, you can say it's like a highly, almost moving towards ideal state. So this was using the function of Excel. So how do we prove that it uses linear regression method? So what we do is, this was auto, right? So this was using automatic method. What we do now is we use the manual method. What do you mean by manual method? So what we will do is we will say is equal to 6268. So we say we have to put the variable, the value of x into this equation to find out y, and we have to match whether it matches the auto condition or not. If it matches, which means we are 110% sure that this forecast function of Excel uses linear regression method. So we use 0.6268 multiplied by x. So x is my number, and we close this. Even if you don't close, it's fine, but because it will follow BODMAS 0.85, and then when we press, so we see that it is showing you the same number. So what happens is, if I just increase it, let me see what happens. So you can see that up to 3 decimal places, it is absolutely giving the same number, same answer. So it proves that forecast function of Excel uses linear regression method, and henceforth what we have seen is that based on, if you have a smaller set of data, you can definitely take help of predictive analysis from Excel and use it to do some kind of forecasting. This is the beginning of any kind of statistical analysis that you do using Excel. We will be gradually moving to Power BI, and then you will see how these things are applied in Power BI, right? So these were the back-to-back two demos that we wanted to share with you, and definitely I hope you have understood, and please feel free to go through these modules, connect with us in terms of any kind of queries that you might have. So we just saw an example of linear regression, how it works. So these regression and the analytical models, they go to the next level also to talk about the multidimensional data model. So these data, small data chunks, what happens is they make up the bigger perspective, or they make up the bigger part, which we call it as multidimensional data model. So Power BI uses this channel of ingesting data in 4 stages. The entire Power BI models, it is in 4 stages. We start from source layer, where you take all the data sources, then we push it to the analytical layer. So we will talk about this, and we will see this in detail, action in detail. But before that, we need to definitely Power BI, right? So that we will see using Excel in our next module. But this is an important part, so we should know how the BI engine, where the BI engine works, and how presentation layer works. These all things we will be looking into in detail, and we will also have a look at how the data model looks like in Power BI when we accept, or when we ingest all different types of data into Power BI. So that was all from part 2 of module 1, where we talked about data storytelling. So if you just can summarize, so we talked about data storytelling, and we talked about the basics of data insights, how numbers and how data points are important in terms of working with the inferences part of it, and also what are the different 2 types of analysis what we work with. So one is the descriptive statistics, and one is inferential statistics. So we will be working on talking more about these statistical methods in the upcoming modules. We have also just touched base the understanding, because we were talking about a demo where we have to make a chart. So chart is nothing but a part of visualization technique itself. So that also we have discussed in detail over here, and also the multidimensional model of BI and how it is used for performing any kind of data analytics. So this is end of module 1 using the insights of data. In the next module, we will be talking about how Microsoft Excel is being used, and for years now it is being used as a self-service BI tool. So we will see the history of this particular tool. We will talk about the history of Excel in a very small way, and then we will gradually move to the different sections of self-service BI tool which is there in Excel. So that is all from this part. Thank you so much for attending this session, this module. So we have completed the first module, part 1 and part 2. Look forward to welcome you in module number 2. Thank you.